So, we have been discussing about these scaling laws of these micro robots. In fact, we had discussed about this rigid body dynamics with reference to scaling laws of rigid body dynamics. So, in this we had discussed about scaling and dynamic forces. Now, we are going to discuss about this trimmer forces for scaling vector. Force scaling vector. So, the trimmer force is a proposed unique matrix to represent four scaling related parameters for acceleration, which we can represent it as A, time, T, and power density, P by V naught. That is required for scaling of system in rotation. So, this matrix has a generic name which we call it as force scaling vector F. So, the force scaling vector is defined as F equals LF, which is L1, L2, L3 and L4. So, we will now derive other quantities based on the above vector. So, one of the quantity which we can focus is the acceleration, which we can term it as A. So, F equals MA. So, in which A equals can be written as F by M. So, the following scaling can be obtained as A equals LF by L cube minus 1, which is nothing but LF by L power minus 3, which can be written as L1, L2, L3 and L4, L power minus 3, which can be represented as L minus 2, L minus 1, L0 and L1. Now, if we take a look at the second part of the equation, the transient time and the subject formula, the relation can be represented as T equals root of 2Sm by F L1, L3 minus F 1 by 2, which can be written as L square LF power minus 1 by 2. This can be further elaborated as L1, L2, L3 and L4 minus 1 by 2. So, L power 2 can be written as L power minus 1 by 2, L power minus 1, L power minus 1.5, L power minus 2, whole power 2, which can be written as L power 1.5, L power 1, L 0.5 and L0. Similarly, if we try to consider the power density, the power density can be represented as P by V naught. So, power is a very important parameter in the design of such kind of micro robots. So, insufficient power supply to these micro robots can result in inactivity of the system. On the other hand, the system may suffer a structural damage such as overheating and excessive power supply. So, excessive power requirements by a micro robot will increase the operation cost, as well as it will also reduce the operational life of such kind of devices when it is incorporated in some field related applications. So, here we deal with the power density. So, when we try to derive the power supply with work, it is required to move the solid with mass m for a distance s. Mathematically, the work done is equal to force times distance travelled. So, that is W equals F into S. Thus, the power defined as the work done per unit time which is represented as P equals W by T, and the power density can be expressed as P by V naught, that is equals Fs T by V naught. So, when we try to relate this power density to the force scaling vector, it can be represented as P by V naught equals LF L1 by L1 L3 L minus F 1 by 2 L3, which can be further represented as F L minus 4 LF 1.5 L minus 4. So, the final power density with reference to force scaling can be represented as L minus 2.5 L minus 1 L 0.5 and L2. So, this is a kind of a relation which basically talks about the power with reference to force scale vector. Okay. Now, let us discuss about the contribution of electrostatic force, how these electrostatic force and electromagnetic force are contributing towards these robotic systems. So, let us discuss about the scaling which is involved in a electrostatic force. So, when we look into the electrostatic charges, so as far as these electrostatic charges are concerned, so these induced an electrostatic force which is expressed by the Coulomb's law, where we have the A, let us consider A with charge Q, D with charge Q, the attraction force F and the repulsion force F, and then there is a distance R which is there between the two charges, which has both attraction as well as repulsion. So it is governed by the Coulomb's law, that is 1 by Q dash 4 pi omega by epsilon R square. Now, as far as these electrostatic charges are concerned, so if we look into the different types of biomimicking robots, in most of the biomimicking robots, these biomimicking robots require certain kind of actuation for appropriate functionality, either for climbing or to adhering to the surface. In case if it is a kind of a targeted drug delivery, it should attack to the surface, etc. So for those conditions, so we are deploying different forces which are being generated. So one of the forces which are prominently used for such kind of micro robotic application is this electrostatic force. Now, when we look into the close application of these electrostatic actuators are used for micromotors and robotic arm. As far as microfluidic perspective point of view, these electrostatic forces control fluid movement in a lab-on-chip devices. Now, one of the key application which is highly focused with reference to this electrostatic perspective point of view is the adhesion and the locomotion. So adhesion of a small micro robot towards a wall or towards the surface to cater different functionality, including the surveillance or including the inspection, or sometimes it is also used for a targeted drug delivery. And another one with reference to locomotion perspective point of view. So when we try to talk about locomotion, automatically the concept of resolution of the locomotion comes into the picture. So the actuation mechanism what we are selecting should have an appropriate capability to have a control over the locomotion. In that perspective, electrostatic force helps micro robots to grip and move on a surface with intermittent displacement. Now, when we look into the biomedical perspective point of view or biomedical micro robots perspective point of view, these biomedical micro robots, it enables cells transport. It is also used for electrophoretic drug delivery as well as biosensing. Now, when we try to look into the overall principle of this electrostatic actuation, as far as in this electrostatic actuation is concerned, there is going to be an external acceleration. A pressure is going to get applied. So these pressure will interact on the material, and finally an electrostatic pressure will be generated appropriately. Now, let us look into some of the mechanisms or some of the fundamentals which are involved with reference to these electrostatic generations and what are the different parameters which caters this electrostatic system. Now, if we look into the overall configuration of these electrostatic forces in a parallel plate, so we have two parallel plates with gap D and length L and a voltage V which is connected to it. So we need to take it into account the electric potential in these two parallel plates. So with reference to the figure, a capacitance C is the charge plate which is expressed as C epsilon R epsilon naught A by D, which can be rewritten as epsilon R epsilon naught WL by D. So the energy associated with this electrical potential can be represented as U equals minus 1 by 2 CV squared, which can be rewritten as minus epsilon R epsilon naught WL V square by 2D. Now here epsilon naught and epsilon R are corresponding to the permittivity and relative permittivity of dielectric medium between two electrodes, and V is the applied voltage across the systems. Now, when we try to look into the scaling of these electrostatic potential, so it is governed with reference to equation 1. So this is a kind of a scaling electrostatic potential which is being observed. So when we try to look into the different forces which are acting in these charged plate, so we can nomenclate these forces with reference to FL, FW and FD. So FD is the force which caters the gap, and FW is the moment along the width W, and FL is the moment along the width L. So in that particular aspect, FD equals minus 1 by 2 epsilon naught epsilon R WL V square by d square, Fw equals minus 1 by 2 epsilon naught epsilon r L V square by d, and Fl can be represented as minus 1 by 2 epsilon naught epsilon r W V square by d. So, from the equation we can say Fd comma Fw comma Fl is directly proportional to L square. So, this is the overall configuration which is followed by these electrostatic forces. Now, a question comes into our mind: why do we require these electrostatic actuation? So, as far as these electrostatic forces, they are ideal for actuating microrobots because they remain strong at small scales. And one of the important aspects with reference to these electrostatic systems are these are well versed and proved systems, and especially on a micron level these systems can be easily manipulated. Yes, so by having these electrostatic motors, MEMS device and electrostatic based micro manipulators are some of the example which basically talks about the application of these electrostatic charges for different systems. Now, one of the key advantage of considering this electrostatic actuation is the gravity scales as k cube. That is, it has a capability to overcome the gravity and the inertia. So, in that aspect, we have the gravity scales which we can represent it as k cube, which basically corresponds to weakening significantly at microscales. In addition, electrostatic forces scale better than the gravitational and the inertial force, which makes them dominant in microsystems. As far as micro manipulation and addition perspective point of view, these electrostatic forces enables a precise object handling, especially it has a potential applications in cell manipulation, micro pick and place robots, etc. It is also used in electrostatic grippers for micro assembly related systems. Now, let us discuss about the overall aspects related to or the overall fundamentals and the parameters which we may need to consider when we are designing an electrostatic based micro robots or micro manipulators. So, these, as we had discussed earlier, these electrostatic charge tend to accumulate on surface due to variety of phenomena like triboelectrification and eventually migrates across insulating surfaces. So, the mechanism of charging is complex and depends on the material considered as well as the environmental conditions. So, when we try to look into this environmental conditions, automatically this triboelectrification effect will have a direct influence. Okay, so furthermore, these electrocharging will result in a kind of a non-equilibrium phenomenon that should relax with time upon contact with the conducting surface. So, to analyze some of the characteristics of electrostatic force, we must first assume two flat insulating material parallel to each other, and the object may carrying a surface charge that will be attracted by the opposite charge on opposing force. So, ideally our assumptions are two flat insulating material parallel to each other So the uniform density of charge sigma, so if we assume a uniform density of charge sigma, the attraction force will be F ELEC Z, which can be represented as QEZ, where sigma S square by 4 pi by 1 by R square. So now if we consider the pressure induced by the two charge is P equals sigma square S 2 epsilon. So this force rapidly decreases with the distance separation between the object. So the peak pressure can be in the order of 100 MPa Newton per mm square. So which it decreases at a pace of 1 by R square. So if we look into the overall typical order of the magnitude of the charge density for an air, it is in the range of sigma S 3 to 10 power minus 5 per meter square, where the gap is close to around 1 micrometer. In the case of a good insulator, sigma S is almost equivalent to 10 coulomb per meter square. So for the threshold charge density, so we will be deploying the breakdown strength is reached and the insulator becomes conductive. For a native oxide like silicon, etc., so the breakdown strength is typically in the order of 30 megawatt per centimeter in air. Okay. So the expression for the force can be generalized in any shape, perfectly conducting the material. So the electrostatic force is calculated out of the electrical energy stored in the capacitor. So if let us consider dVc, that is d corresponds to the distance separating the two charged bodies, V is the voltage and C is the capacitance. The force is given as F equals minus half DC, F equals minus half DC by D V square. So the main issue which is involved is in the determination of the capacitance. So some analytical solution will help us of some particular geometries and range. For instance, for a sphere or a flat surface with an approximate force, so it can be represented as F equals pi epsilon naught R square V square by D plus R. Okay. So this is the overall force which will be generated, which is considered for an appropriate approximation. Now, under these particular conditions, like with reference to electrostatic perspective point of view, so we have different forces which are being exhibits. Now, extension of this electrostatic force, we have the electromagnetic force. So let us discuss the scaling effect in electromagnetic force and some of the different capillary forces which are contributing towards adhesion in detail in the upcoming lectures.